The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, ladies and gentlemen. Welcome to TechGeek webinar series, our endeavor to empower techies. We believe that sharing of knowledge is key to enhance our skills and grow us as a professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is MariaDB, MySQL indexing, and the best practices. In our panel today, we have two guest speakers. Our first speaker is Mrs. Sonali Minocha. She is lead database practice at OSS Cube, and she will be the lead speaker today. Our second speaker is Mr. Anurag. He is also associated with OSS Cube and will brief us about OSS Cube and its functioning. So without any further delay, I introduce you to all our guest speaker. Over to you, Anurag.
Hi everybody, thanks for taking time out of your busy schedule for this webinar. I will start with a small introduction of OSS Cube and Sonali, who is the speaker today. OSS Cube is a global solution provider. We deliver integrated mission critical solutions using open source. We work across customer for more than 16 countries and deliver robust, scalable and high performance solution using open source technology. We are the world only Zen Center of Excellence, and we don't use open source for the solution. We also actively contribute to the open source community as well. The second slide basically shows that we are the integrated business solution provider in the sense that we have a broad set of competencies, but our greatest strength and what separates us from other open source solution provider is the ability to integrate many applications into a solution that can help to meet customer business objectives. As you can see, Talent, Cloudera, Sugar CRM, Magento. We are the Sugar CRM Platinum partner. We are the Talent only partner in India and Asia Pacific. We are the Amazon Advanced Consulting partner. We are the Zen, the world only Center of Excellence. So these are the various open source products through which we work to develop a solution. Coming into OSS Cube MySQL services, we are into remote DBA. We do a lot of performance tuning for various clients. We also help in setting cluster application, MySQL development services, and we also do remote and on-site training requirement. The speaker today is Sonali. Sonali is an internationally recognized database expert with a 10+ years of hands-on experience. She is a well-known MySQL consultant and has the distinction of being Asia's first woman certified MySQL DBA and India's first MySQL authorized instructor. Her expertise has been routinely sought out in setting up clusters, optimizing performance of large folders, and delivering MySQL trainings to several Fortune 500 companies. Now I will hand over to Sonali to take you through the webinar. Thanks.
Thank you, Anurag. A very good afternoon to everybody, and thank you so much for taking out time and sharing the thoughts on this topic. So what is the next 1 hour is going to be? So it's all about performance. What is the most frequent recommendations in the database performance audits which you get in your company once you are doing an audit of your portals or your websites or your application? What is the most important recommendations that you get? What is the easiest way of speeding up your SQL queries without any database schema change and without any code change? So if you think, the answer is one, and that is index. So the next 1 hour is going to be about indexes. So what we will cover is understanding the indexes, choosing best MySQL index strategy for application, and MySQL index limitations and MariaDB new features along with MariaDB index limitations. So let us start. So see, what is an index? So even if you don't know database, index is something very common which everybody of us knows. We know books where we have got a lot of data stored in, and at the back of the books you normally find an index pages. So what are those pages? Those pages are nothing but the reference to the actual content of your book. So even if I don't understand a database, I still understand what an index is. So it's a book which has got a lot of chapters, got lots of data stored into it, lots of keywords. The important ones which I tag, which I number it and keep it in my index, that gives me a flexibility of going to the few pages of indexes, figuring out what I'm looking for. From that reference, go to the actual content which I want to read. So like we use in a book, it is the same we use in a database. So in a database, we have an actual table which has got huge large set of data which can be referred to directly. Obviously, the efficiency is going to be less. If I have a thick book and I'm finding on the pages, let's say I'm finding on something, maybe let's say a skeleton system. I find a book of a human beings and something, I'm finding that skeleton word will definitely take me a longer time rather than going to an index, figuring out the page number and going to that page. Same way, in a table, in a huge table, if I am finding some data, if I put an index on it, it becomes easier. So it is nothing but a data structure that improves the speed of the data retrieval operations on a table. It's a mechanism how you locate your data in the table. So very simple to understand what an index is. But how we design an index? So when we are talking about designing your database, do you design your index strategy that time? Maybe yes, maybe not. Your RDBMS is designed based on your data. However, your indexes are not designed or decided by the data you have. It is decided by the queries you want to execute on that data. It is decided by the strategy of the indexes is not about the data. It's about how you want to retrieve the data. So these are the few basic things which are about indexes, which are very basic things, and I will take you forward from these two slides very quickly and move on to the more topics. So it's a speedy retrieval of data. That's why we use indexes. For random lookups, for efficiency in reporting OLAP and read-intensive applications, the indexes are required. So if indexes improve my performance, so can I index every column in my table to increase the performance? Maybe not. The reason is every index you add decreases the performance of your update and writes. The way I was talking about books, if you make some entries into the data of your book or you add some new chapters, you have to go to your index, index pages, make an update in the index, then only your index will be updated. Otherwise, the entry of the new chapter is not going to be in your indexes, and in fact, your old indexes, the old index pages are also going to be redundant because the new entry has happened and the page numbers have not been revised. So every time you have to revise your indexes when you are updating and writing. So I may be very smart in thinking that, okay, it's about faster retrieval. I put up all the indexes on all my columns, and eventually this is the best way of killing my application. Over-indexing is the best way of killing your application. You over-index your application, it will hamper the performance of your updates. It will hamper the performance of your writes. It may give you a good performance in read. So it says you have to decide what kind of an application it is, whether it's a read-intensive application or a reporting application on OLAP. So many indexing can be, adding more indexes can make more sense. However, if you have a write-intensive application or an application which gets updated very quickly, definitely the over-indexing will kill your application. That's why I said the right indexes are crucial to speed up your queries. Most workloads are read-heavy, so the net benefit of indexes overweights the overhead of updating. Indexes are compact, so they are more efficient use of buffer memory. Indexes can be created on one column or created on many columns. Indexes may be unique or non-unique. For example, as we move forward, we will see there are indexes like primary key, unique indexes, which are unique in nature. But it is not necessary that you have a unique indexes always in your database. It can be unique, it can be non-unique. Yes, definitely we will talk about the uniqueness, non-uniqueness, till what limit you can have a non-unique index so that it does not adversely affect your application. We will take that forward. Index may quote one or more columns and be means of enforcing uniqueness to their values. So these are the basic things. So let's see, there is a one table, let's say employee table, which has got various fields like employee ID, first name, last name, age, salary, and gender. And what we want to do is, this is a table. This is the data we had stored. So when I was designing this application, let's say an employee management system, I designed a table employee where I have created the various columns where the data is going to be stored. But I have not decided what indexes are going to be applied to it. The indexes are applied once I know what kind of a data retrieval I want. So let's say in this table, I want to read out a row where the name of an employee is Ronnie. So what it internally converts into the form of this code. For each row in the table, if row 2 is Ronnie, then result is appended to that column. This is how I write a code for searching each row in my table to locate an employee whose name is Ronnie, because I'm not using any index. So that's why the larger my table is, my full table scan will happen, and I will scan each row, find out where the Ronnie is, and finally display the result. So definitely the performance is worse. So now let's see how the database works with indexes. So as you see on my screen, there you see these are the indexes which are created on this column, and they are doing a linking of the various data. So this is an index which has just got the address of the data where it is captured. When I'm looking for any employee ID, it just goes to this table or whatever I'm looking for, it will find in the index file. The moment it finds the index file, it goes to that particular address and reads it. That's how the basic understanding of indexes is, how the indexes work. Now let's see how the indexes are implemented in MySQL and MariaDB. The index implementation of MySQL and MariaDB is almost the same. In MySQL 5.6 and in MariaDB, there are few things which have come up, which is like push down things, and we have several things which we might be talking a little later. Other things which are new features in MariaDB. Apart from that, all the functions, all the type of indexes which are available in MySQL are applicable to MariaDB also. So these are the major type of B trees, R trees, and hash indexes. This is how your indexes are internally stored. Definitely, the way the MySQL stores your indexes, the way the MySQL implements your indexes defines how efficient that index is going to be when you are firing a query on that particular index. There are B tree. So you see that there are B tree indexes which are most common index type. This is the most common index type. However, the implementation in MySQL and InnoDB, which are the most commonly used storage engines, is slightly different. You have the R tree indexes, which is majorly used in MySQL. However, from MySQL 5.1 version, it is going to be available in InnoDB also. There are hash indexes which exist in memory and NDB storage engine. They are a special type of implementation, the way the indexes are stored. %90% of your time which will be spent working on the B tree indexes only. And this is the major focus on this presentation also. When we record the B tree indexes, if you create the index with MySQL with a B tree, we are really speaking about a family of different types of implementations. There are different type of B trees also which are implemented, like B plus tree, B minus tree, which are implemented. Depending upon the storage engine, you may be looking at a B tree index, B plus index, tree index, and NDB storage engine, or the red block tree index for the in-memory storage engine. It is very important to know that the practical implementation is with regard to what kind of queries these indexes can optimize. So whenever you are talking about any of the indexes, you can you have a limitation where you can define which storage engine has which kind of a index. So might I have a query which I know might use a B-tree as a better solution, but I want to implement a hash, and maybe this particular storage engine does not support it. So that may be a limitation which you will find out when working with MySQL. There are certain type of indexes, the way they are implemented can be implemented only in a particular storage engine only. So once we go ahead, you'll be able to appreciate more what I'm saying. So let's start with the hash. So what is a hash? So you must have heard about something called as a hash and a bucket. So every key is bucketed using a hash function, and that bucket points to a particular function. So you have a key here on which you put some hashing algorithm, and the hash value is the address of this bucket where the actual data is stored. The key of the hash table would be based on the table name, column name which you want to, and the data will be pointed to the database row. Hash indexes are good for the quality searches. Hash indexes are not good when you are doing not the quality searches but the ranges. Range means I want to look for all the employees whose employee code is between 1 to 100. Then obviously if I am using a hash kind of a index, that is not going to give me any kind of a performance. That's going to degrade the performance of my read. So it is better to use another kind of an index which we have been talking about, that is a B-tree. B-tree is better implemented and it is better used. The efficiency of the B-tree is much more apt to the range searches which we are doing. However, if I want to look for an employee whose employee ID is, let's say, 3001, then definitely hash is a better kind of an index. So depending upon the kind of queries you want, depending upon the kind of searches, that should be one of the parameters of thinking whether you can use a B-tree or a hash tree. But as I said earlier, remember the B-tree and the hash tree has a little bit of flexibility when you're talking about storage engines. So there are storage engines, specific storage engines which implement a different kind of indexes. So in a B-tree, the data is stored in an orderly manner. That means when I am storing the data, there is a range how it is going to be stored in. So if I am making an index on an age, let's say, and it is a B-tree, it will be orderly saved in the ascending age of the employees. So because it is stores the data in an orderly way, so definitely when I'm searching the data, it knows from which node to which node it has to read data, and that's why it is more effective when we are talking about doing a search in a B-tree rather than doing it in a hash type of indexes. So what happens in the B-tree is you have a single disk operation. Each node takes up of the one disk block, goes to the data, reads the data and return it. Now that's the implementation part of it. Hash, B-tree and RT are used for different strategies to speed up your data retrieval. The best algorithm is picked up depending on the data expected and supported algorithm. This is what I was saying, that obviously the kind of data you are expecting and the algorithm, which algorithm is supported by which storage engine defines which kind of indexes you can use. So that is how they are internally implemented, and as a DBA or a developer, you might not be changing those algorithms very frequently, but as a DBA, this is something which is a very basic to understand and very fundamental understanding to create the most efficient indexing strategy for your application. So there are different kinds of indexes. One is a column index, concatenated index, covering index, partial index, clustered and non-clustered indexes. So let's see what is a column index. Column index is nothing. When you create an index on a one particular column, it is called as a column or a single column index. So for example, you create in an employee table, you create an ID on an employee ID, index on employee ID. That is a type of a column index. This kind of an index are very good and they give a very efficient performance in the case of a data lookup. So for example, if I'm looking for any employee with a particular ID, definitely an employee ID will give me a one-to-one relationship between my index and my data, and I can retrieve the data very quickly using that particular index. So this is a kind of an one column index. So it becomes simpler because here I have only got one column. I have one column, I select that column, I am using that in the index and I get the data. This column index in my example is showing as a primary key, so it is unique. However, that's not required. A single column may or may not be a primary or a unique key. So this is simple to understand. When I create an index on a particular column, good. I just use it in my query and it helps in the relevant searching of the data and gives me the result faster. But what is a more complex thing to understand and how it is implemented is a concatenated indexes or a multiple indexes. What is a multiple index? Multiple index is an index, as the name suggests, is an index which is created on multiple columns. With a multiple column indexes, we have two or more columns almost concatenated to form one index. When you are creating a multiple column, there has to be something which you have to keep in mind, that is the sort order within those defined. Because the way your query is going to use this multiple index can only take the advantage of these columns, indexed columns, if the first column is compared, then the second column, and then the third column, and then the so forth. It is important to understand that for a multiple column indexes, there is still one B tree that is created. Not any kind of any other structure is created, just one B tree. There is only one B tree where the comparison rule is applied, or from the first column to the next column and in the index. So the order in which you define your index is very important. Here in the example you see that I have created an index on first name and last name. Whether this indexes will be used when I am searching or not is also dependent. That we'll see what are the cases in that. So this is something very important to keep in mind. The order in which you are defining indexes in multiple index. This is something where the most important slide of this presentation, because in a real world there may be many cases in your application where you are defining multiple column indexes. So which query will use that multiple index and which query is not? This slide is really going to help you to understand that better. So when you see this, I have created an order in a multiple columns and the index is called as ABC. So when I am running any query where I say select something from table 1 where value of A is greater than 5, the index will be used. However, if I use the same range function on a second column defined in the index, it will not be used. Had it been A, when I'm saying, okay, let the value of A is greater than 5, I was able to use the capability of this index. However, when I say B is greater than 5, I am not able to use the capability of this index. Same way, when I say the value, select something from table 1 where value of A is greater than 5 and B is equal to 2. Then only a partial index will be used, only this will be used and this will not be used. So you have to be very careful in understanding the multiple index which you have defined in your query, which index will be used, which part of your multiple index will be used and which part will not be used. Then if you see that if I am doing A is equal to 5 and B is greater than this range, I am able to use the capability of both. See, here I was not able to use, when I am saying B is greater than 5 alone without using A, I was not able to use the index B. However, when I'm saying a comparison, equality comparison of A with some value and range on B, I'm able to use the same index. However, if I convert this B greater than 6 to some value and C, because I'm not using index A here, definitely the entire index is not used in this particular case. When I say A is equal to 5 and B is greater than 6 and C is equal to 2, we will use B as the range only. So when you say A is equal to 5, B is equal to 6 and C is equal to 7, yes, we can use it. A, B and in this value this can be used. So you see there are many combinations and permutations in which the multiple column indexes will be used. This is the thumb rule when you are defining an index. Because when you are deciding an index, it is better to, rather than, when you create an index. When your developer or your DBA comes to you saying the performance of my application is degrading, you try to analyze the queries and you try to add indexes to that. So when you can't just randomly add index to that. So when you are adding an index to your database, just figure it out whether the earlier indexes, the old indexes are present. If not, then when you are creating a new one is better or extending the old index is better. For example, I had an index on A. Now I have written a query where I'm trying to do a search on B also. So will it make more sense for me to create an index B individually or extend my index A to by creating an index A, B? So what is a better way of doing it? Think before you simply create a new index over that. However, the multiple indexing, the way you are using it in your searches, the way the MySQL optimizer or the MariaDB optimizer is going to behave, that you have to keep in mind. So let's recapitulate how the optimizer behaves in case of ranges when you're talking about multiple indexes. The multiple indexes was not used when you were saying the second column in the index was done a range search on it. Because the MySQL optimizer does not use the range and the between keywords when you are using a second or a third column of your index. However, there is a workaround of the same. If you want to use it in the multiple index, then you can use in. For example, I was saying that I want to have a value of B between 1 to 5. It will not use the index, so it is better to rewrite your query saying search in B where the value of B is in 1, 2, 3, 1, 2, 3, 4, 5 rather than saying between 1, 5. The output is going to be same. Obviously, the efficiency of this particular query, if the using in, is going to be more than a query which is using between. So that was the case when we are talking about using a searches or range searches in a multiple index column. Now, when you are talking about using a multiple in the case of sorting, how it behaves. You have an index where you have created on two columns A, B. Now, when you are doing sorting or an order by on this particular index, whether it is going to be used or not, let's see. So you have an order by saying column A. So what it does is you are just sorting it by the first column. So it uses this particular column and sorts your data. However, when I say I want to sort using B, it does not allow me. So again, I want to say that once again, the order in which you are defining your index is very dependent on the way you are going to fire your date queries. So if I have many queries on which are requiring an order by column B, then this particular index should not be created. Then I should be creating an index saying index B, A. So depending upon your requirements, you have to decide the order of your index, order of your column in the multiple index. So same way when you say A is equal to 5, order by B, filtering by the first and sorting by second is allowed. However, when you say I'm doing ordering I am doing some calculations on this. See, this is the same query, but this only works when you have an equality comparison here. You have a range comparison here, that's why this does not work. Rest all the same. It is just the equality and the range, which makes a particular index, decides which particular index the optimizer will be using and will not be using. Second is when you're doing an order by on two columns, they should be using the same sorting technique. So if A is descending and B is descending, that is going to work. However, if you're saying order by A as ascending and B as descending, this will not work. So if you order by on two columns that are a part of a single multiple index, then the ordering strategy, that is ascending or descending, whether descending, has to be same. So when you are saying A is greater than 5, order by A, this will work. And when you say in and order by B, this is not going to work. So let's say once again, we can definitely say in cannot be used by the MySQL optimizer to effectively get your data from a multiple column index in which the in is used. Sorting order, ascending or descending should be same, which I have shared with you. Only equality comparison can be used in the column which is not in the part of the order by. So if I go back to my slide, you will see that this was not the part, this was the part of the order by, that's why you were able to use it. This was not the part of the order by, that's why we were not able to use the indexes. So that was on the multiple indexes. Multiple indexes are a little bit complex because you have to remember always the order in which you have defined those indexes and then see which query can be using that index and which query cannot. Then we move on to something called the covering index. Covering index is actually not an index, but it's a condition in which your entire data is returned back from the index itself. It doesn't have to go to your data files to map the data and give it to you. So that's why the covering index is a very efficient way and very fast way of getting your data. The benefit of covering index is that it looks up to the various B3 index spaces necessarily, satisfies the query, and no additional data lookup is required. So it is just a condition in which by chance which I was selecting the data, it happens to be a query index, and I just have to go to the index file, read the entire data, and get the result back. So if you see in this query, it says select employee ID from employee, where employee ID is 001. So right now I'm just looking for an employee ID where it matches, so I get this data back. However, if I modify this query by saying select employee ID, employee name from employee, definitely my result set is not only going to get the data from the index, it has to look to the name also, which is stored in the data file, so I get back the results from the data file. However, because the employee ID is index, the efficiency of my query is low. Even if I select the employee name is going to be higher, however, it is not going to be as fast as just selecting the employee ID. But remember, we cannot do this mistake of creating all the indexes on all the columns so that whatever I select is always going to be having a covering index. Because that is, as I've already shared with you, the larger number of indexes you have will have the adverse impact on your updates and deletes. So what your covering indexes can be used and where it cannot be. For example, I have a column, let's say on salary, which I have created an index, and I was just doing select salary from particular table employee and where the employee ID is equal to 001. I will definitely get the result from the index itself because salary is indexed. Whenever I'm trying to find out a max or a minimum of a salary, I can use this function. However, any aggregate function like average or any other function cannot use covering indexes. So covering index is good as far as you know what kind of data you are looking. So this is also again another tip which one should follow when you're writing your queries. We should avoid writing select star from tables. It will be great if you write the particular columns which you are looking for, because might be most of them are indexed, and you never know you get a result from the covering index then we are talking about a partial or a prefix index. Why it is required to have a partial or a prefix index? It is important because the thumb rule of the index should be the thinner your indexes are, the more indexes will fit into your one memory block. The more indexes fit into one memory block, there will be faster read because they don't have to swipe into the other memory blocks. So the more thinner your indexes are, the better it is for efficiency. So for example, I have got a varchar or a text column, which is a very huge column, and I want to try and I want to index that. So if I create an index on the entire column, definitely it will impact the size of the index, and definitely it will increase the data lookups on the disk as required. So what we can do is, to avoid this situation, we can create indexes on a prefix of an index. So let's, as you see in my example, we have created a table tree where the name is a type of a character data type, where I have 255 characters defined. Index we have created on the only first 15 characters of it. So this will help us to improve the performance of the index, as the index is thinner than comparing if I create an index on the entire name with 255 characters. But one disadvantage of a partial index is that it can never take an advantage of covering index. Because now we have partially indexes. For example, if I have created a partial index on last name, definitely the index file will not contain the full last name. So when it goes to a search on a last name, it will never be able to get the data from the index itself. It always has to go to the data file to get me the data. The other thing which one should keep in mind when you are defining a partial index is there should not be too many rows sharing the same prefix. So let's say that we have created an index where we have said on name, we will create an index only on 4 or 3 characters. Let's say on 3 characters, then the selectivity might not be a good idea in this particular case. Let's say we have a name called Sonali, Sonia, Sigma, all this. When you are using an index only on this, the result which you will get of the index search is not going to be as efficient as if they were not sharing the same prefix. So you have to see what kind of a data is there and what kind of uniqueness you can maintain by selecting only the prefix of the data. So now we have something called as a clustered and a non-clustered index. So what is a clustered index and what is a non-clustered index? These are the two different types of indexes which are used by the two different types of storage engines in MySQL. MySQL uses a non-clustered index, whereas InnoDB uses the clustered index. So what it means is, MySQL and InnoDB tables, they are a little bit different. In MySQL, the data pointer points to the physical object in the data file, so all the indexes are essentially equivalent, whether that's a primary key, unique key, or a secondary key. They all are same and the way they behave. However, it is different in case of InnoDB. In case of InnoDB, there is a primary key which can be created by you, and even if it is not created by you, it will be implicitly created whenever you create any index on the InnoDB table. This is special because it stores the data in the leaf pages and not to the pointer to the data. The secondary index stores the primary key as a data pointer. So what happens is, because the InnoDB indexes are clustered, they always club your primary key with the secondary index, whatever you create in an InnoDB storage engine. So in a clustered storage engine, you always have a physically sorted data like you have in a telephone directory where the name is sorted, let's say by a last name or something. So you will always have the data sorted in the order of your primary key, and then you have the secondary index. Your secondary key will always include your primary key. That is the reason why you should be very, very careful when you are selecting the size of a index primary key in case of an InnoDB storage engine. So let's say you have created an in case of an InnoDB, you have created an index primary key, say employee ID with integer 10 bytes or something. So this integer will always be added into the secondary indexes. Even if I create an index on employee name, this employee ID will be added to employee name. So you should be very careful with the size of the InnoDB primary key. So this is what my next slide says, that the key should be very small as possible. Primary key should be as small as possible in case of your InnoDB storage engines. Okay, so now we learned about how the indexes are implemented, B-tree hash. We have got different algorithms, how they are implementing different types, where you have column, covering, partial, multiple. But how to figure it out whether my query is using that index or not? That we use with a tool which is called as explain. I'm sure most of you must have run that. This gives me a query execution plan in this database. What does the query execution plan does is, whenever I'm firing any query, it does not actually go to the storage engine to get me the data. It only gets me to the optimizer. How the optimizer is planning to get data for me, that is decided and returned to me by explain. So if you see here, you will see that I have run an explain on a select where ID is equal to 1, this type, this is a type. This type says how the data is accessed from this particular city list. So the entire data was scrolled so that I got the entire data out and displayed in the form of a record set. So it says no possible key, no key was used. And because obviously it was no key, no prefix, so obviously the key length value is always going to be null. And this tells me how many rows it is going to extract. So the explain is very important, which tells me which query is using my index or not. So definitely when I run an explain on select star from city list, it gives me an idea that if I put an index on this, definitely I may get a better results of doing it. So how, but okay, we got that when the index is created. There are multiple indexes which you have created, which you might have already created in your database on your different tables. How the optimizer is going to decide which index it is going to use. In MySQL and MariaDB, the dynamic picking of each query execution plan is done. Even if you have a prepared statement, you do not have something called as the execution plan already created and reused. Every execution plan is new when you are executing a query. That means it has an advantage. Your execution plan is always relevant to the current set of data. For example, you will agree to me that data is fast growing. You have a set of a data. Whatever strategy I am using to fetch the data right now from my table might not be valid after 10 days when my data size is increased. And now I may be searching some data with an employee whose IDs are between 100 to 200, and then I might be searching the other day the same data with employee IDs more than 250. So definitely there are certain databases who keep their execution plans stored. However, in MariaDB and MySQL, you do not have any execution plans stored. So it does a dynamic picking up of your query execution, dives into your data, estimate how many rows will be accessed. Depending upon the minimum rows, it follows that strategy or that optimization plan to execute and actually get the data from the storage engine. So there is a coordinated statistics which are available with the optimizer to decide which execution plan it is going to follow. If that's not available, then there is something called as an analyzed table, which you might have done as a DBA. There are few queries which we execute very often. So one of this will update the MySQL optimizer to figure it out which tables or how the actual execution of the query should be done. When you are joining, for example, multiple tables, table 1, table 2, and table 3, from which table you should first retrieve the data and then join with which table is all decided by the optimizer, and how the optimizer is going to how the optimizer is thinking of retrieving the data, that you can figure it out by using an explain. So the optimizer not only uses a strategy of minimizing the row scans. For example, let's say we have table 1, 2, and 3, and optimizer thinks that if I read the data from table 1 and then join to label table 2, it's going to be lesser rows which are returned because the table 1 has got lesser rows than table 2. Might be that can be one of the strategies with the optimizer thing, and there are certain other things also like covering index benefit, whether it can use or not. Full table scan is faster at some times. So all these parameters which your optimizer thinks and decides how it is going to be executed. So that's up to the optimizer. So you run explain, you figure it out whether the index is there or not. Okay, now we decide that we have to create an index because the explain was not using an index. So the selectivity is something which you should keep in mind when you are designing your index. When you are deciding which column is going to be an index, the selectivity of that particular column should be one of the major things which you should keep in mind while defining an index. Selectivity is nothing but it is a ratio between the distinct values or the unique values you have in your table and the ratio between the number of total values you have. So obviously your primary key will always have the selectivity 1. That's 100% because in 10,000, 2,000 employees, whatever number of employees you have, your primary key is employee ID, which is always unique, so selectivity is high. So you should always try to have those indexes in place which has got higher selectivity because that's going to give you a better performance results when you are doing your search queries. For example, if you want to create an index on a gender which has got mainly 2 values like male and female, obviously selectivity is going to be 2 divided by 10,000 employees, which comes out to be 0.00002. Definitely having an index on this column, I'm not sure how much efficiency it will increase in your read, but definitely it will hamper your updates and deletes. So you may figure out there are certain indexes which you should drop, because of which the performance is not increasing. Actually, the performance of your application might be decreasing. So how to find out which columns or which indexes you should drop? Any index which has got the selectivity percentage below than 15% should be reconsidered and rethink whether they can be a good candidate for indexing or not. So this is one criteria. The other is you can write a small query on your information.schema where you can figure it out what is the cardinality and what is the selectivity of your index or column. So depending on that, you can decide what are the good performing and what are the worst performing indexes. So then you can figure out what are the best performing indexes, continue with them, and you can think and revisit the idea of dropping the worst performing indexes. So you have an information schema table in the MySQL database where you can figure out statistics. You can find out the statistics of all the tables of all the databases, and I don't want to have the data from MySQL database. That is a database where you have user table and all. And the post table, I don't want to use it. Apart from that, give me the cardinality and of all the databases, and that will help me to find out what are the selectivity of various indexes in my particular database, and definitely I can decide on whether I want to continue with those databases and whether not. So these were the case where we decided, okay, this is a place where we should drop the indexes, like agenda, which I'm not sure how much efficiency it is increasing. The selectivity was less than 15%. You might find out some dead indexes in your application that at one point of time some developer came and created some index. Now that index has never been in use. There are certain tools which you can find. Many tools are available on site which is called as double deck checker. Double indexes are created on indexes. So you can also look on those duplicate indexes and drop all those indexes. So that means the lesson from this is that tidy up your indexes. The neater your indexes are, the efficient your system is going to be. No dead indexes should be there. No duplicate indexes should be there. No indexes with the selectivity less than 15 should be there. So once you clean your database, you do a housekeeping of it, you tidy up your indexes, then think about where to add indexes. So the way to add indexes is after we have found out that okay, there are certain columns on which we are doing a regular select, you should add an index to it. That means a where condition, where I say select something on a where. When I'm using a where as a filter clause to filter the data, then I should be using a where condition. Index those columns on which we are doing a join. When I'm joining a multiple tables, the columns on which I'm using a join should be indexed. All the columns where I'm using a group bar is also an important candidate for adding an index. Shared with you earlier, avoid using redundant indexes. Should not have redundant indexes. In this case, you have CA, AB, prefix of A. So depending on what your queries are, few of the queries might be using only one index and rest might be the dead indexes. So depending upon this, you should figure out which column indexes you should drop. So this is something very important in MySQL, which is called as a key cache. Key cache in MySQL is a cache which is assigned where it stores the keys or the indexes. There is a buffer which stores that indexes. Because the index is loaded in the buffer, the reading of those indexes becomes faster. So in your application, you might find out instances there are certain tables, the efficiency of which is expected to be very high as compared to the other tables. Then what you can do is create indexes on that table. Then you cache those indexes into hot cache. Definitely that will always keep those particular indexes in the cache. Now because they are in cache, the reading from those particular index and even the index has to go to the data file, get to the data, becomes more faster. So this is called as something preloading of the data and keeping it there. So this is something which you should always keep in mind. When you are using a functions on your indexed column, it is not going to be used. So this is the same query which is going to give me a same result where I'm using, in a where condition I'm using 2 days, date of joining, and now this less than this does not use an index. However, in a same where condition, I have taken the index column out of the function. So I'm not using 2 day now. I don't have a 2 day here, and I'm using it like this, and it uses an index. So you should be very intelligent to find out in which condition your index will be used and in which condition your indexes will not be used. So same case, like you have a select star from employee where the name was this, or let function in this. Here you will not use an index, there you will use an index. So these are the tips which I have already shared. I'll just go through them quickly. Consider the column selectivity. Indexes has to be as small as possible. Take the advantage of the leftmost prefix because which in turn will have a smaller data type. Use a slow query log. This is important. This is an ongoing process which you should do. Reading your application's database, how it is performing, how your queries are performing, whether your index strategy is which you have applied once is applicable today or not. Is a question which you have to answer every time. Make it a habit because one index strategy you have created for one set of data might not be applied to the same set of data again. The larger your data set becomes, your strategy might have to be different or might be the same. So make it a habit of going to the enabling your slow query logs, recording the queries and figuring out whether it requires a performance tuning or not. Performance tuning should be a habit rather than doing it once in a while when you have stuck with a bottleneck or where you want to improve your performance. Keep your data types as small as possible because they are going to be indexed. Finally, they will have a smaller index. In a more records in a one in a block. More blocks means faster retrieval. The common mistakes you do when you're doing, we all do an indexing is not using an index. Composite index is something which I have shared is very critical, the order in which the columns are defined in the index. Using an expression on a column which is indexed, I have shared, and appending a primary key index to an InnoDB table, because the primary key is always attended to the secondary keys. So that's all from my side. Any questions you have, I will be more than happy to answer them.
Yeah, thanks Sonali for the insightful presentation on MySQL indexing practicing. Let us quickly take up the questions now. I request you to please read out the questions as well as their answer so that all our users may listen to the commendable insights. So,
Sure.
so please go to the question tab. There you can see the questions.
Gaurav, I don't see any question there. Okay, I got one. I got a question with respect to query performance improvement is concerned. What all necessary decisions that developer DBA needs to be taken before adding index for a stored procedure? This would be critical since having a combination of select, insert, and update statements in a stored procedure. Considering adding index on a select query, please advise. See, it depends on what is the responsibility of your stored procedure. In fact, it is a better idea to divide your stored procedures into a select stored procedure, insert and update first, if that's to have a smaller stored procedures. If that's not possible, obviously reading is going to have a good impact of your index. If you are not having too many indexes, definitely your updates and inserts are not going to be that hampered. So you have to make a conscious decision of balancing out which is more important in this particular stored procedure, which is not. So I'm not saying even adding a one index in a particular table will impact the insert and update with that adversely. However, if I'm never doing any select from that particular table, I might not require to have an index. Then why should I have an index or an insert table? So that calibration you have to do. So I've got another question. Does multiple index work for like? Yes, it does. But for example, if you want to do like percentage A, it will not work. That means any while character should be followed by a fixed character. When I'm saying select name from employee table where last name like A followed by percentage will work. But A percentage will not work. A percentage will work. Percentage A will not work. The next question is, does most of the concepts are applicable to MySQL Server database as well? Yes, actually the basics are same. Maybe the B tree implementation part which I was talking about is not same how it is done in MySQL. I'm not very sure whether it's done in that way. However, otherwise the kind of indexing, covering indexing and everything which you are talking about, having our indexes smaller, all the tips and tricks are definitely applied to MySQL also. I have another question which is how to estimate how much size would be required to store data in the database. Actually, it depends upon what kind of data you want to store and how much is the expectation that what kind of data is going to come. Then you decide about the different data types, and then depending upon the data types, you estimate how much data is going to be stored in the database. There are certain formulas which I think Gaurav will be sharing with me your IDs and all. I can send you more details on this question then. Gaurav, I think all the questions are answered.
So we are getting a lot of questions, Sonali, please.
But I am not able to see them on my screen.
Please go to the question panel.
I got that. While sorting multiple indexes, is there any specific technique will be used or not? If so, what is technique is used? Actually, there is no specific technique when you are doing the sorting on the multiple indexes. The only key rule is the first column has to be defined. The slide which I have shared, which clearly shows the order of the columns in the multiple indexes, is very important. There is no particular technique, specific technique that will be used or which I can share with you, or you can define the technique. It is just the order of the columns which has to be taken in mind. The kind of query is the sorting order, or order by or the group by which your query is used. Depending upon that, you should define the order of the columns of your indexes. The difference between a B tree and a clustered index. Clustered index is definitely a B plus tree, where the secondary index, that is the secondary tree in B tree index, has the pointer which points to the primary index. In a InnoDB, what happens is your primary key last nodes or the leaf contains the actual data. However, the secondary index in the InnoDB clustered index, the last leaf does not point to the data, but it points to the primary key. So that is a clustered index, where the primary key leaves contain the data which is pointed by the secondary key. You said if you create a more index, it will affect on insert and update. If I create more index only for sorting, that cases would it affect? Is your application only using sorting the data? If your application is only and only read intensive, where you are just doing sorting and you are not doing an insert and update, definitely you can add columns for your sorting. That's what I'm saying, that you have to do a balancing between what kind of an application it is, read or write intensive, and then decide how many indexes you can afford to have. Let's move on to the next question. How true is that using a subquery makes query slower? Lakshman, that's very true to some extent. In MySQL 5.3 before and 5.3 or 5.4, I'm not sure, the subqueries were not optimized for execution. So internally, whenever you wrote a subquery, it was internally converted into joins and created a temporary tables to return the data. So obviously the subqueries were not at all optimized in MySQL. However, that is true for all databases. The subqueries performance is much slower, not much slow, but yet comparatively slower when you talk about writing joins. So the best practice should be try writing your queries in terms of joins rather than your subqueries. The next question is, what is the best way to add index on live table? How to avoid read or write blocking? Actually, there is no best way of adding it on the live table. There are limitations with it, and the writing will be blocked for sure. Because when you are doing a writing at the same time and you are creating an index, so definitely the new record addresses will also be updated into the indexes, and they are not updated. How many indexes used in a table? See, there are around 64 or so numbers. Not very sure about this number, maximum number, but it is around 64 which you can create on a table. Definitely that is not something which one should try out, because as I shared, over-indexing is the best way to kill your application. Can we create a bitmap indexes in MySQL? Yes, like you have in Oracle, the bitmap indexes are not that commonly used in MySQL. There are versions of MySQL which are upcoming and they might be using it, but as of now it doesn't. We have 25 fields in one clustered index, and rest of all the fields have non-clustered index. How it is going to impact the performance in the query? I think there is a question which says we have 25 fields, one is clustered index and rest of all the fields are non-clustered index. How it is going to impact the performance? See, this is not clustered or this is not unclustered. I think the question is that we have 25 fields, one is a composite key or a clustered and the rest of them are non-clustered. I am not sure about what this question is trying to ask, so maybe I need, maybe you can rephrase this question and send once again.
Please skip that question if in case the question is incomplete. Please move to the.
I'm not able to.
Yeah, please, Sonali.
Yeah. How to check table efficiency? There is no way to check the table efficiency. There is a way to check the index efficiency. I have shared with you a script where we are doing a selectivity. You have to figure out what is the selectivity of the index and observe your queries whether they are using the index or not. Then only you can find out the index efficiency. What are CSV tables? CSV tables are actually nothing but there is a kind of a storage engine in MySQL where you can store your data in the form of a CSV file, which is basically not very usable. It is normally used for dumping the data or archiving the data. How and where can I find the other rules regarding the order of operations and component indexes or multiple indexes? Will it vary from different vendors? No, it will not vary with the different vendors. However, the more rules and more in-depth knowledge of indexing, you can find there are many links which you can find on the website about indexing. The MySQL tutorial itself, where you'll be able to find out there are many ways where you can figure out which kind of indexing strategy is fit for you and what rule should be applied when you are doing a sorting on a multiple columns. I think, Gaurav, all the questions are done now.
Yeah, Sonali, we are done with the question and answer part. We are still getting a lot of questions from our participant. I request you to please take up it personally when we share all the questions once we are done with the session. Right?
Sure, I will do that.
Right. So I'm really thankful for taking so many questions and conducting this webinar. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of this webinar will be available on our website, that is techgeek.com, by tomorrow. Thank you all. Thank you, Sonali. Thank you, Anurag.
Thank you. Thank you, Gaurav. Thank you, everyone, for your time and listening to me patiently.
Thank you. Have a nice day.
Thank you.